Yeah, so again, also this week, a very warm welcome from my side to everyone who joined our digital coffee break. As last week as well, essential requirement, the coffee for this week again.
Yeah.
So for those of you who don't know me yet and don't know AppWorks, my name is Angela and I'm responsible for marketing at AppWorks. And for those of you who don't know AppWorks, we are a 100% subsidiary of Premium Aerotech and part of Airbus. We design, develop and manufacture products which exploit the benefits of additive manufacturing. And before handing over to our speaker of today, just some technical remarks. So all of you can see below of your screen a Q&A session. So whenever there arise some questions or you have some remarks, feel free to add anything, and whenever Joachim is finished, we will go through those questions and try to answer all of them. Yeah, so then it's time to grab your coffee, lean back and listen to Joachim Zettler, our speaker of today and CEO of AppWorks.
Yeah, thanks, Angela, for the kind introduction. A warm welcome also from my side. The title of this quick coffee break today is Aerospace Qualification for Additive Manufacturing. And I'm speaking to you today not as the CEO of AppWorks, even though I am still the CEO, but also the head of additive from Premium Aerotech. And I mean, for all of you who do not know Premium Aerotech yet, they are one of the world's largest tier 1 aerospace component manufacturers, located in Germany, and our shareholder. And I'm in this lucky position to head their mainly aerospace focused additive business as well. So what you will hear now in the next couple of minutes is an excerpt from our day-to-day activities on how we qualify aerospace components that really fly in the end. And the good thing is, whatever you see in the upcoming slides can be also applied to your business. So we are not linked to only work with Airbus. We can work with everyone out there, even with direct competition like Boeing. And I mean, we all know current times are not that easy. So let's see if we can push or break through this Corona crisis also with some additive in the end. So a lot of people and in various talks, no matter if you take Formnext as a good example last year or various industry talks, it's all about qualifying components, no matter if it's for aerospace, medicine, or any other serious application. In aerospace, we basically divide the world into qualification scenarios. One is the process qualification, and the other one is, let's say, a part qualification, where you, for a specific part, qualify a process and the whole chain to fit the requirements of your customer. This is something that is of not too big interest for Premium Aerotech and also for AppWorks, since in the end, we are in the service provider business. So we would like to produce a lot of components, various components for our customers, no matter if it's Airbus or any other customer. And therefore, we need to be able to do that as cheap as possible. That's why a process qualification is far more attractive to us, since we can easily switch various components as long as they are fitting in our qualification to additive. And that's why right from the beginning, we never really focused on part qualifications, even though we also know how to do that. We nearly always focused entirely on process qualification for the laser powder bed process. And so how have we done that? I mean, meanwhile, we have this process qualification. So we are approved from Airbus based on the latest AIM, so Airbus industry material specification and Airbus industry process industry norms. So we are basically qualified to deliver flying components up to a functional class 2.1. So you can see this below here. So functional class 2.1, for all of you who are not so familiar with aerospace declarations, it's basically, it's a fatigue loaded component. And how did we achieve that? Basically, you have to focus on one type of machine. So we, in this case, work with concept laser M2 type system. It's a dual laser system. The build space can be seen here, 250 by 250 by 280. And let's say everything, before you start such a qualification, everything needs to be predefined. The layer thickness, the gas atmosphere, the machine type, in this case the M2, the process parameters. And you're also not allowed to change this any time after you have done this process qualification, since otherwise you might lose it and would have to do a delta qualification again. So this is how we started it. Basically, this exercise is meanwhile repeated on other machine types as well. So it's basically, it's always the same procedure. It's just an additional effort. You have to print various coupons, test them, and I will come to that anyway in a minute. What is the outcome of this qualification? Because in the end, it's not only about printing. What you finally have to do is you have to qualify the whole process chain. And as you might know, the AM process is just a little part of the whole chain we focus on. So on top here, you can see the current environment. It's a rather old picture here. Meanwhile, we have 6 systems up and running for aerospace applications, some systems where AppWorks mainly focuses on for non-aerospace applications as well. But more or less, the process is always the same for aerospace components, at least for aerospace components out of Type 6.4. So this is the material of choice we started with. We print the component. We apply a kind of either wire EDM or cutting. For Type 6.4, it's always wire EDM right now. Then we apply an appropriate heat treatment process, hot isostatic pressing process, mandatory for all the parts we produce up to now. Then non-destructive testing in-house, chemical milling with the supplier. Then we do the machining in-house, crack testing, final surface protection in-house, and of course, last but not least, the final QA. And all these process steps are more or less qualified, not less. They are all qualified, otherwise it would never work to finally deliver a component that will, let's say, be placed into an airplane, no matter if we would do it with a certificate of conformity, so a COC, or an EASA Form 1, which is in most of the cases the documentation we deliver with the component. As we focus mainly on Type 6.4, I just wanted to give you a quick overview what we can achieve with the laser powder bed process, because sometimes we hear rumors in the marketplace, with additive we are not able, to reach the quality criteria that are necessary from industry, that we know from annealed plate or forgings. But you see, if you apply it correctly, and in this qualified environment we are in, these are real-time and real-life values we can easily achieve meanwhile, and you see we are not too bad. So I think this is up to you to interpret these values now and compare it with your own investigations. Besides these basic parameters to justify if a material is built up correctly, of course, we also tested various properties from density to the more exotic ones: shear, fracture toughness, fatigue, limit crack growth, surface influence, chemical composition, the microstructure of the part, and samples. And I mean, all of this exercise is just there to demonstrate to the authorities and also to our customer Airbus in this case that we nearly have no spread in this process. So if we would come up with A and B values, as you can see it here in the specification, for example, for yield strength, we would have to achieve a yield strength of 830 megapascal. And overall, we are always above these values, with always taking into account the statistics already. The same applies to ultimate shear strength and ultimate strength, not shear strength, and the elongation at break. And this gives, only with this very, very demanding test program we had to apply. And I think this one, the number of specimens larger 100, this is just for a single test. So more than 100 coupons at room temperature from the various process steps have to be produced, machined, and last but and for each and every individual process step have to be tested in the end, to be really on the safe side that whatever we print fulfills, let's say, even higher demands than traditionally known for plate material, for example, which sometimes can be also a little bit annoying, that we have higher demands on additive components than on classical components machined out of a block of material. So let me check what else. Given that we now have this process qualification, as mentioned initially, it's not very difficult for us to work with various customers. I mean, it's true that right now our main customer is Airbus. And I mean, with Airbus, there are always two scenarios. In a build-to-print scenario, we take the part documentation from Airbus and the drawings from Airbus, and we, according to the drawings, we apply a build-to-print process internally. We do a first particle investigation on new components. A very specific set of testing needs to be applied, even in a process qualification environment. And then last but not least, we will be able to deliver all these parts based on our process qualification with an EASA Form 1 certificate to the customer in the end. We can also do this with as a sub-tier supplier to other suppliers that provide components to Airbus. So let's take an example. Liebherr, Lufthansa Technik, Moog, no matter who will supply a component to Airbus, we could be the one to easily supply this component to this tier 1. So we, in this case, we would act as a tier 2. We will supply the component with the EASA Form 1 according to the same specifications. In this case, not directly to Airbus, but with a POA-DOA agreement to the tier 1 supplier, and then this tier 1 supplier can use the documentation we provided to him and deliver it to the final customer, which in this case has to be Airbus, since we still focus on AIMS, AIPS, PI, and TM in the end. So, of course, given that we now have this knowledge how to handle these EASA-inspired aerospace processes from Airbus, this can also be easily transferred to other OEMs, Gulfstream, Boeing, you name them. I mean, it's quite easy for us knowing now how to dig our way through this whole certification jungle. It's also easy to come up with customized solutions, no matter where the customer comes from. And with such a setup, we can basically switch every component where there is obviously a positive business case overnight to an additively manufactured component using the laser powder bed process for titanium 6-4. And I mean, if you are a non-Airbus customer, this is just what I meant. There are multiple solutions we can help you. Basically, we would never say it's not working at all. We never found any case where we had no idea. Even with the FAA, we had multiple discussions. So if you are a customer working in the non-EASA world, it's also not a big problem. Most of the stuff, if not nearly everything we do for EASA, can be easily applied to FAA regulated industries as well. So that's it, basically. I mean, to conclude, what you see here are one of the first A350 parts we qualified, and that they fly in A350s all around the world. They range, it's 3 components. Overall, it's 6 because they are symmetric, but it's in the end 3 part families, so to say, and they out of titanium 6.4, and you will find them in the door surround area of every A350 flying around. So any questions? I hope there are some.
You can find the questions in the Q&A, Joachim.
Ah, yeah, okay. So do I have to type it or can I answer it?
You can directly answer
Maybe
it.
I will
read
just,
it and answer it. Yeah.
Yeah, exactly. Then every one of you hear it. So Priyanshu is asking, is HIP in-house or with a supplier? This is really is it the only one? No, chemical milling is also done outside. So HIP is done outside with a supplier network. I mean, we investigated quite a lot if it makes sense to insource HIP, so hot isostatic pressing, but in the end, let's say the business case is nearly not given. I mean, we would benefit a lot from the lead time decrease having HIP in-house, but from a pure financial perspective, it's just not an option for us right now. The amount of parts we have is not enough yet to justify such an investment. So I hope this did answer the question. So Martin, you asked, are you able to redesign 3 classically designed parts and substitute it with 1 AM part, including Form 1? Yeah, definitely yes. I mean, we have the engineering capabilities, we have, I mean, the process capabilities you saw already. So this is an easy exercise for us. Ah, Jürgen, good to read from you. How is the AppWorks business share between aerospace and non-aerospace for Type 6.4? Very simple, AppWorks has no stake in aerospace. So AppWorks, to be very clear on that, we focus on everything besides aerospace, while Premium Aerotech, our shareholder, focuses on everything meant for aerospace. And also in the future, right now it's Type 6.4, but maybe in the future we will also see, you know, high strength aluminum like Skalmalloy applications in Premium Aerotech. So this is basically the high level split. Aerospace, Premium Aerotech, non-aerospace, AppWorks, and there are some applications in between, like high volume automotive serial production. This is also stuff Premium Aerotech is heavily involved in. GM, you ask, what influence do you see on Type 6.4 from powder humidity, and how do you control this factor? In the initial investigations we made, I mean, we did not only analyze powder humidity, we analyzed the chemical compositions, flowability, you know, the usual stuff I guess most of you in this call are familiar with. It has a huge influence, and we control it in a way that I mean, you know, these Airbus specifications are very limited in terms, there is no room to play around. It's clearly mentioned where you need to end up in terms of humidity level, flowability, chemical composition, and so on. And so we just align to this and actually have no problem. I mean, we do quite a lot of chemical analysis throughout the life of the powder, because we also reuse the powder several times. But we always have to make sure that we are still within the range that is required by the specifications. So I hope this does answer this. Then what else do we have? Stefano, you asked, do you have to go through a full qualification for every part, or some results can be used in multiple parts? I will answer it how I understand it. So for every new component, even though we have the process qualification, we still have to do a kind of a first particle qualification. This has to be done every time. So usually you align with the M&P department of your customer, or the demanding party, and they tell you how many, you know, specimens, what kind of specimens you have to test. Then you print these jobs, you test them, and if everything is fine, then you come up with an FBQ report, and this is signed and approved, and then actually you can start with the part production. So what you usually save if you have a process qualification is not entirely the qualification of new components. It's mainly lead time, you can just move faster, and usually the costs are lower compared to always doing a part qualification for every new component. Yeah, so Priyanshu, you answered already to my answer, which is good. It was related to the hip. If you do it in-house or in-house, outside. So, oh no, you just confirmed that. That's good. So what else do we have? I hope I pronounce this correctly. Köhn Huybrechts, you ask if we needed any input from Concept Laser during the qualification process. Yeah, trust me, we needed a lot of input, since this whole qualification, I think for every OEM, machine OEM, this is still a special procedure, because, you know, it's also not so easy if you, for example, encounter, I don't know, maybe software issues during the qualification. And normally what will happen is you would do a firmware upgrade. Unfortunately, just doing a firmware upgrade would result in redoing the whole qualification from the beginning again. So it's quite tricky, and also the lessons learned for, and you can take Concept, EOS, SLM, Additive Industries, whomever you want. This is a tough exercise for this whole industry, but meanwhile, I guess also the machine OEMs are much better prepared to support every individual customer on that journey. Then Rob did ask if we have already qualified the process. I mean, besides the laser powder bed process, if we already qualified any other AM technology. Not yet. We are working to qualify direct energy depositions or wire feed processes as well. Then Priyanshu again, if we are also using Skalmalloy for aerospace. I think I mentioned that already. It's definitely on our roadmap. Right now, besides aerospace, we see a lot of very good feedback from the marketplace. I mean, this is basically the AppWorks business. Skalmalloy is, yeah, it's really a unique selling point on that respect. For aerospace, it's still in qualification, so it will take a while. It's not yet fully qualified, and one of the main reasons for that is also that it's quite hard, even with such a high strength aluminum, to come up with interesting business cases, because machining aluminum is really, really cheap, and you have to not only squeeze out weight, you have to do much more that using Skalmalloy or using in general additive manufacturing makes sense if you focus on aluminum. Yes, Stefano, I think I answered partially your question already. You asked if we changed the software version of the machine, new build processor, whatever. Do we need to go through a full qualification? It's never a full qualification, but yes, definitely you have to prove again that you still comply with the specifications, whatever you change on the system. Massi Tamela, you ask how much automation is used to screen possible parts and to redesign them to be additively manufactured. We use a lot of automation, meanwhile, to quickly scan large amounts of databases or large amounts of data from various databases. However, this is, you know, just a coarse filter. Whenever you really dig into the let's say the outcome of this coarse filter, there is still a lot of manual work needed, and you need to put in a lot of engineering effort to really identify the interesting business cases. Easy business cases, you know, brackets and stuff like this. This can also be done automatically, but the outcome of these exercises was, I would say, not always very successful. That's why we put a lot of engineering effort into this to just come up with interesting parts that we can finally print and switch to additive in the end. Then we have, I think, also an interesting question some of you might be interested in. How long will it take for such a process qualification? Usually, with the knowledge we have today, 6 to 9 months, depending if the qualification body, so and also the customer are willing to support. because you always have to work very closely with the respective material and process department from the customer. And let's say if they are fully overloaded and cannot provide any support, then obviously it will take longer. But a lot can be done in 6 to 9 months. Eliana, good to see that you're also online. Have you started laser DED work with Skalmalloy yet? Besides partial applications, so really specific applications, we never focus really on flying components yet. So also on the DED side, we mainly focus here on Ti-64, not on Skalmalloy. I mean, we know, or we have ways now to produce the wire according to spec and cost, but the applications are still, yeah, it's tricky to come up with interesting applications that make sense from a business perspective. Stefano, you ask, are qualification results linked only to the machine or also to a specific platform layout? Right now we focus on specific machines. In the future we intend to focus, let's say, on a specific platform. So to say, if we, I mean, now you saw the M2 type machine, and ideally we have an M2 type platform where we just place one M2 machine next to the other and we know it will work. Unfortunately, it's not that easy today. So right now it's really machine specific still. Then Oliver, you ask if we also plan to work with 3D printed polymer components. Today we focus entirely on metal, but who knows what will happen tomorrow. I mean, we have some R&D activity going on also on polymer printing, but nothing yet to be qualified nor delivered to any aerospace customer. Then, yeah, that's also an interesting question. The business model of AppWorks, are we now a job shop or what are we? We are something in between. I mean, with Premium Aerotech, it's pretty simple. They are, let's say, yeah, top-notch aerospace supplier applying additive manufacturing, let's say, to come up with even more interesting solutions for our customers. So Premium Aerotech, I think this is a no-brainer what they do. On AppWorks, we can also do basically the job shop business. So build to print. You send us something, we just produce it. But what we see is the marketplace is not educated well enough yet to make this business model work. So if we would just do that, we would already be bankrupt. That's why we have quite a heavy engineering team to help our customers come up with interesting applications. So we do the application development jointly with our customers to have something that we can print in the end. So that's our business model. Developing applications and then manufacturing these yeah, newly developed applications for our clients worldwide.
Playing the bad guy, Joachim. So
I need to check how many questions we still have.
You choose another 2 and then we will answer the other ones afterwards.
Yeah, let me check. So maybe this question from Philippe is interesting. What is the process you follow to select specifically the concept M2 machine? I mean, we have a quite in-depth industrial process to select not only 3D printers, but also to select, you know, in general machinery for aerospace production. And this procedure was basically applied to the 3D printers as well. So we judged on, I mean, together with our M&P colleagues, we decided on what is really necessary, how can we measure stability of the system, how can we measure the uptime, the OEE values of these systems, since it's a new industry and there are not so many experiences yet. But in the end, meanwhile, we have a full-blown industrial process applied to every new machine purchase. So various RFQ rounds before we really select, let's say, a new machine, including also that each and every individual supplier has to print and demonstrate really that they can comply with AIMS and AIPS requirements already. And yeah, and last but not least, I think this is also an interesting question. Do you CT scan 100% of your parts? There we have to distinguish a little bit what's the functional class of these parts. So functional class 2.1, definitely 100%. And then it depends if you go down a little bit to functional class 3 or 2.3. It really depends on the outcome of the M&P investigation, what we finally have to scan. So it's not really a yes, it's also not a no. I would say right now for the parts we have changed already to additive, I would say 70% of the parts are scanned. Yeah, so I guess even though there are some more questions, but I think we have to, the timekeeper is already.
I'm playing the timekeeper. I will, we will have all the questions written down, so whenever there are some still unanswered, we will go for them afterwards, I think. Yeah, so
absolutely.
Thanks, Joachim, for the presentation, and a special thank you to everyone who handed in questions. It was like really nice to receive so many questions and to have such a interactive discussion. Good to see that it created a few questions and that we received so many open questions to answer and to give our opinion on. So I think we are good for today, and we are already looking forward to seeing you next week. For those of you who will join again next week, we will go for polishing AM parts, which is another good input, or you receive another good input on additive and what you can do, especially for that, let's say, topic which is always discussed on surfaces of 3D printed components. Yeah.
Interesting topic.
Thanks everyone for joining. See you next week then. Stay healthy, stay safe, and see you next week then.
Same from my side. Bye-bye to everyone.
See you. Bye.
Stay healthy.